Greetings and welcome to the O-Level Revision series. In this video, we'll be starting off the A-Math chapter on polynomials, focusing on definitions and basic operations. The success criteria for this video would be for students to be able to first determine if a function is polynomial, 2, to state the degree, leading coefficient, nth term, and the coefficient of the nth term of a polynomial, as well as to add, subtract, and multiply two polynomials together. We begin by defining a monomial, which is the building block of the polynomials. A monomial comes in the form of ax to the power of n, where a is a constant known as the coefficient, and it can take on any real number. The coefficient is multiplied to x, which is called the variable, something we haven't determined yet, and unknown. And n here is referred to as the exponent or the index. For a monomial, this exponent has to be a non-negative integer. For example, 3x to the power of 5 is a monomial. When monomials with different exponents are added together, we get a polynomial. The term with the highest valued exponent determines the leading coefficient. So for this example, the leading coefficient is 3. That highest exponent is known as the degree. So here we have a degree 5 polynomial. Sometimes this is also referred to as the order of the polynomial. The other terms are referred to by their exponent. So for example, 7x squared is the x squared term. At the very end, you see the negative 5 that is independent of x. This is sometimes referred to as the constant term. Here we have some examples of polynomials and some special names for them. Functions that are independent of x have a degree of 0 and are just constant. A function like 5x plus 3 has a degree of 1. We call it a linear function. When the degree is 2, we get a quadratic. Degree 3 is known as cubic, and degree 4 is known as quartic. Moving on to exercise 1. Can you identify the polynomials among these four expressions? Pause the video here and give this a good try. Let's see if you're correct. These are the two polynomials. This one isn't a polynomial because of the 1 over x. That is the same as writing x to the power of negative 1. And we know that for polynomials, the exponents have to be non-negative. In the bottom right example, we have a square root x. That is also not allowed because the exponents have to be integers. Exercise 2. Complete the table below for the three polynomial expressions. Write down their degree, their leading coefficient, their constant term, and the coefficient of their respective x squared term. Pause the video here and give this a good try. So for part A, the degree is 2, the leading coefficient is 1, the coefficient of x squared is also 1, and the constant term is negative 9. In part B, the degree is 3, the leading coefficient is negative 4, the constant term, it looks like it's not there, but it's just a plus 0, so the constant term is 0, and the coefficient of the x squared term is negative 6. For part C, we'll first need to expand this. Next, we can see that the degree is 8, the leading coefficient is 24, the constant term is negative 3, and the coefficient of the x squared term, well, there's no x squared term, so the coefficient is just 0. Let's now look at how to add two polynomials together. This is a basic recap of Sec 1 algebra. Looking at the blue and green quadratic expressions, we add the like terms together. So, like terms are terms where the exponents of the variables are equal. So the like term of 5x squared is 6x squared, and we add them together. The like term of 3x is negative 2x. We add them together. And the like terms for the constant terms are just each other. So negative 4 plus 7. So simplifying, we'll get 11x squared plus x plus 3. Now for subtracting two polynomials. So now I'm going to subtract the green quadratic from the blue quadratic. You will just have to be a little bit more careful because there's an opening of brackets here. So we'll get 5 minus 6x squared, 3x minus negative 2x, so that will be 3 plus 2x, and we'll have negative 4 minus a 7. So when we simplify this, we're going to get negative x squared plus 5x minus 11. Exercise 3. I have two polynomials, px and qx, a cubic and a quadratic. In this exercise, evaluate px plus qx as well as 2px minus qx. Pause the video here and give this question a good try. Let's go through the answer. So px plus qx is as follows. First, let's look at the cubic terms. So we have 4x cubed. Well, 4x cubed has no other cubic like terms to add together, so it's done. For the x squared terms, we have a 3 and a negative 6x squared, so we add those two together. We have a 5x as well as a negative 2x, so we add those two together. And for the constant terms, we have a negative 1 and a negative 8. We add them together. So after simplifying, we'll get 4x cubed minus 3x squared plus 3x minus 9. In part 2, first we'll need to substitute the px and qx, and we'll need to open up the brackets for 2px. So we'll get 8x cubed plus 6x squared minus 4x minus 2. We can also open up the brackets for the minus qx. So that will give us plus 6x squared minus 5x plus 8. Then this becomes polynomial addition. So again, the x cubed term has no counterpart. We'll just add the x squared terms together, so that's 6x squared plus 6x squared giving us 12x squared. The x terms, which is negative 4x plus negative 5x giving us negative 9x. And negative 2 plus 8 gives us positive 6. So that's our final answer. Lastly, in polynomial multiplication, this can only be described as painful, very painful. Basically, we need to do a rainbow expansion and ensure that all the 3 terms in the first polynomial is multiplied against all the terms in the second polynomial. This, because we have 3 terms and 3 terms in the 2 polynomials, 3 times 3 is going to give us 9 terms. So let's do this methodically. We start off with 4x to the power of 5, and that's going to multiply with 5x to the power of 4. So 4 times 5 gives us 20. X to the power of 5 times x to the power of 4, using our inverse law, you will get x to the power of 9, which is 5 plus 4. We add the exponents together. Next, we take 4x to the power of 5 and we multiply it by x cubed. This will give us 4x to the power of 8 multiplied by the third term in the second polynomial. So this will give us negative 8x to the power of 6. So we're done with 4x to the power of 5, the first term in the first polynomial. So let's move on to its second term. So negative 3x squared times 5x to the power of 4 gives us negative 15x to the power of 6. The negative 3x squared times x cubed gives us negative 3x to the power of 5. And multiplied by negative 2x, we're going to get 6x cubed, because negative 3 times negative 2 is positive 6. So we're done with the second term in the first polynomial. So let's move on to the last term, which is the constant term 7. 7 times 5x to the power of 4 gives us 28x to the power of 4. 7 times x cubed is 7x cubed. 7 times negative 2x is negative 14x. Now you can see we get 9 terms in total. But we are not done yet. we need to look across all these 9 terms and look for like terms to add or subtract together. You'll see that we can still simplify. You can see that negative 8x to the power 6 minus 15x to the power 6 gives us negative 23x to the power 6. 6x cubed plus 7x cubed gives us 13x cubed. So our final answer is just a polynomial with degree 9 and 7 terms. Exercise number 4. Can you expand these polynomials? So in part I, expand 2x minus 1 multiplied by 4x squared plus 2x plus 1. In part 2, expand x squared plus x minus 1 multiplied by x squared minus x plus 1. Pause the video here and give this a good try. So let's just go through the answers. I'm just going to give you the answers and see if you get the same answers. So for part I, you're just going to get 8x cubed minus 1. It turns out that a lot of terms will cancel each other out in this. This is also the famous difference of cube factorization. In part 2, when you expand this out, a lot of people will kill each other as well. All you'll be left with is x to the power 4 minus x squared plus 2x plus 1. So did you get these answers? So we've come to the end of the video. Let's go back to our success criteria that we've set out at the start of the lesson. Are you now able to determine if a function is a polynomial? Are you able to state the degree, the leading coefficient, the nth term, as well as the coefficient of the nth term of a polynomial? And are you able to add, subtract, and multiply two polynomials together? Now, if you have any questions on any of these, please leave a comment in the comment section below. So we've come to the end of part 1 on basic operations of polynomials as well as the basic definitions. Do stay tuned for part 2, where I'll cover the thing that I casually omitted in part 1, which is the division of polynomials. That is because division isn't very basic at all. So we'll spend one entire lesson looking at long division as well as the synthetic division method. Anyway, thank you for your kind attention and have a good day of learning.